Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Bommer. This is their part number LB4390C 400-630. This is a single acting spring hinge. That's what it looks like. This is made of solid stainless. Let's dissect the part number. First of all, the LB in the part number stands for Lube bearing. That is inherently a three-knuckle type of construction from Bommer. When we get into it being an LB4 or 4.3, that means it's a spring hinge. It's a three-knuckle spring hinge. The 90 in the part number tells us that it is a contract grade, meaning it's 130 thousandths thick because of the 4-inch size, and that it has locations that are in the template pattern. The template pattern is I wouldn't say universal pattern, but if anyone's manufacturing hinges and doors and frames to the template pattern, it's universal when used in that sense. Okay. The C at the end means contract grade. It means it's, again, 130 thousandths thick. That's because it's a 4-inch hinge, a 4-inch tall hinge. My caliper tells me that leaf is 0.139. 0.139, so a little heavy. Yeah, 138, so that's not going to be a problem. I would expect it to be, closer to 130 thousandths, which is what a 4-inch hinge would be. Now the 400 in the part number, that means that this hinge is 4-inch tall and 4-inch wide. 4-inch tall and 4-inch wide, and 400 is the Bommer code for a hinge that is 4-inch by 4-inch. The height is the first dimension on hinges like this, and on most hinges. So just be mindful that when you are calling out a hinge, you're talking about the height as the first dimension. Doors are backwards. The width is the first dimension. And while it's usually not, such a critical point to, get it right that the height is first on a hinge and the width is second, it is something that you need to understand. That's how it's defined. If someone says to you that they want a door and a frame and they want 4x6 hinges, that's very different than saying I need 6x4. So a 4x6 would be a wide throw hinge, and it's 4-inch tall, 6-inch wide, probably wood door and wood frame. But a 6x4, that's a very different animal. 6-inch tall, that could tell me it's hollow metal, door and frame, extremely heavy, extremely wide door, and that they want such a tall hinge on. So the point of the matter is, it's important to know the height is the first dimension, because not all hinges are square. Many are rectangular, like a 5x4.5, like a 4.5x6, like a 4x3.5. Very common in aluminum storefront is 4.5x4. Hollow metal is typically 4.5x4.5, but that doesn't mean it's the right hinge to use. 4x4 tells me it's very likely some sort of residential application, meaning it's not a hollow metal frame, even though it could be, and not a hollow metal door, even though it could be. It could be a fiberglass door on an aluminum frame, stainless hinge. Why would they spend all the extra money for solid stainless if it's not a coastal or exterior environmental sort of application? I might suggest that it's the size and the base material all lead us towards kind of excluding what it's not, and that height being the first dimension is the crucial reason for thinking what you might be thinking. 630, that means two things. Actually means three things. Well, it means two. It's made of solid stainless, and that it is in a brushed finish. Those are the two things. The third thing is that stainless with a brushed finish is the most durable of all finishes. It's called a natural finish, and by far the most durable. Nothing is more durable than that. Someone might say, well, give me satin chrome. That's pretty durable. True, but it's a plating over steel or possibly brass, but it's a artificial finish. So if you're looking for the most durable finish, it would definitely be 630. You could also do this in 629. It would be solid stainless, but they would polish that to a mirror finish. And does that make it less substantial in terms of its ability to withstand the effects of the environment? No, it's just probably not going to be super shiny forever. like a polished stainless would be. Okay, so this is a spring hinge. Where would you use this? Well, you'd use it anywhere where you want the door to close behind you. This is also a listed hinge. That means that it bears evidence at the testing laboratory that this hinge was found to be compliant with the requirements of the fire test that it was subjected to. It's also labeled. It's listed. The evidence is on file at the factory of passing the test. It's labeled, giving you visual indication that such has occurred. When it comes to spring hinges and fire-rated doors, there are a few, most likely, mandatory requirements. NFPA 80 is the standard that defines, that outlines and defines spring hinges for use on fire doors. If your local code references that NFPA 80 standard, that standard is now code because it's in the code book. And what that says basically is there is a limitation, 3070, in terms of a fire door. You must use at least 2 spring hinges on a fire door, and it must be labeled. It has to be listed, but it has to be labeled as well. Visual evidence that it has passed that test. I have people that call, I have one client call one time and say, where's my hinge? Well, it's on order with the factory. As we discussed, it's 2 or 3 weeks. Well, I've got an inspection coming. We have to get this going. I'm going to buy another hinge. Okay, what are you going to buy? Well, I'm just going to go down the street and get this hinge. In fact, I already got the hinge. And I say, okay, well, I understand what you're saying, but look at that hinge. Does it have a label on it? Is it stamped, listed? No, it's got nothing like that. It just came from the home center, and I'm sure it's made in China. Stop. That hinge is not permissible for use on a fire door at all, nor would it be nearly as high caliber as the Bommer hinge. Bommer is extremely proud of the engineering and material science of everything that's happening inside of this barrel. I've been to the plant. I have literally been in the room where testing occurs, and they are hyper proud because of the testing standards to which they have subjected this construction to. I was speaking to that engineer who I was at back of house with, and this is a grade 1 hinge. It's rated to 1,000,000 cycles. And I says, you know, how many cycles will your hinge go to? We were talking about the spring construction in here, etc., the design construction, because Bommer will tell you they make the best spring hinge in the industry. And I asked how many cycles it had been tested to. We know 1,000,000 cycles is required for grade 1. He says, I don't know. I pulled the plug at about 9,000,000 cycles, and I don't remember what he meant. It said it was like 4,000,000, 7,000,000, 9,000,000. Next time it'll be 40,000,000. But he says, I pulled the plug on the machine at X million of cycles. He says, I don't know. It just kept going. I didn't see a reason to let it keep going. So very, very high caliber hinge that you're getting with Bommer. In fact, a company who invented the entire category of spring hinges, both single and double acting. There is some supporting documentation down below. Let's switch to the screen view and take a look. Okay, so here's the item that we are looking at. Extended description here. Part number. All right, so full mortise hinge. We'll talk about that at the end and in a moment. Contract grade meaning it's thicker. It's not residential grade. This is UL listed for use on fire doors. Grade 1, non-handed. You can install this on any of the 4 ways a door can swing if it's a swinging door. Self-lubricating bearings. Easily adjustable spring tension. I'll demonstrate that before the end. ANSI templated screw hole pattern, and I'll show you that on the template. Pivot point aligns with commercial butt hinges between 123 and 134 thousandths, obviously 139 thousandths in this case. That means if you're going to mix and match hinges, you have to be sure that the hinge you're using that's not a spring hinge is between this range in terms of the leaf thickness. Also, if you're using a non-spring hinge, put that at the top. Make it ball bearing and put it at the top, because the top hinge does 70% of the weight. 70% of the weight of the door is hung off that top hinge. The middle and bottom are doing far less work. That's where your spring hinges need to go. Made of stainless with square corners, 8 holes. Recommended maximum labeled size is 3070. That's not a recommendation, that's a mandate. We'll talk about the weight range of your door depending on how many hinges in a moment. If you were to require more tension pins or a tension rod, they can be ordered at those 2 links. Now, speaking of links, Okay, so we have our template, and the template's going to show us everything dimensionally important about the hinge. The locations for the holes for your fasteners. If you're not sure if this is going to match, print this out, take it with a tape measure to your door and double check. It's 4-inch tall, 4-inch wide. It's full mortise, meaning when the leaves are brought parallel, they're meant to be mortised flush to the edge of the door and frame, showing the leaf thickness here. And what makes that possible is the swag, the bend on the hinge leaf right here. That's what makes it a full mortise hinge. The next document is, this is the, and by the time you're seeing this video, this will be fixed. This would be instructions, and these are, if your hinges come in a box, it's probably printed on the box, but if it doesn't, well, here they are. The bottom line is, and I'll demonstrate how to set tension at the end, you basically hang your door without any tension set on the pins whatsoever. Get the door hung, then set your tension. With the tension collar pointed towards the top of the door, you'll insert the tension rod, just like it's showing here, and turn it clockwise. Into one of the new revealed holes, insert your tension pin. Get that set to the point where your door is closing and latching correctly. Make sure your tension pin is set flush as possible to the outside of the barrel, and in order to do that, you have to have the tension rod only inserted into the hole of the tension collar enough, because that tension collar is crossbored. There's a hole all the way through, there's a hole all the way through, there's a hole all the way through, there's a hole all the way through. If you've got this going in too far, you won't be able to get that in far enough. Okay. If you are going to 180 degrees, don't exceed 3 holes. If you're going only to 90, you can go up to 4 holes. And everything here should be what I just said. Then there's a link called, I think this one's called Certifications, or will be called. This tells you how many hinges you need depending on the weight of the door. A 4x4, 85 pounds, 2 spring hinges and a butt hinge, make it a ball bearing hinge and put it at the top. If you're going heavier than that, go all spring hinges. Okay. These notes down here reiterate, if you're mixing and matching, what hinge to use. The notes up here talk about NFPA 80 and the requirements. Maximum labeled door size is 3070 per NFPA 80. You must have at least a minimum of 2 spring hinges on a labeled fire door. All all Bommer LB4390 series hinges are UL listed for fire rated doors up to 3 hour, provided that you meet all of the requirements. NFPA 80 if you are in the construction industry, along with NFPA 101, if they are very much worth owning, because they are the governing information, certainly when it's been adopted into code. Those NFPA 80 and 101, NFPA 101. There are others, but those are, if you're going to have 1 or 2, those are the 2 to have. NFPA 101 is on it's egress code. You know, it's building construction as it pertains to occupancies and what can and can't be done. But the focus on fire rated, it would be NFPA 80. Non-labeled doors, have at it. Maximum door width, they say 4 foot. If you want to go to 8 foot, great. Add another hinge. Now, speaking of quantity of hinges, I'm a fan of all spring hinges when it makes sense to do so. And obviously when it makes, when it's mandatory that you have all spring hinges. What I mean by that is environmental conditions change. You know, you might have in the summer doors and windows open where that door slams. You can relieve that tension by moving the tension pin over. But in the wintertime, when you have the opposite condition, you might need the ability to increase that spring tension. The point is, as we discussed earlier, you can only go so far on the quantity of holes that you'll set tension on. But having more spring hinges rather than less gives you more ability to have greater amounts of stored energy when the door is going through its final few degrees of the closing cycle of the door, because you want the door to close, but it's not really good enough if it's not latched. And a door has a tremendous amount of square footage of air to overcome as the door pushes through that space. It's displacing all the air that's there, the weight of the door, the resistance of the latch bolt when it hits the strike plate, etc. The spring that's in there. Let's switch this video back to the camera and touch on the adjustment portion of this. Okay, so the hinge that we have here, that's the tension collar. Install that with it pointed towards the top of the door. You can do a left hand, you can do a right hand, doesn't matter. You can also do it this way if you want. But when the tension collar is pointed towards the top, you're going to take that tension rod, you're going to stick it in a hole and then turn it clockwise. And into one of those new holes is where you'll set or insert the tension pin. For every hinge that you order, you'll get one tension pin. For every order that you place, you'll get at least one tension rod. Okay, and that's how you set this tension. So it's pretty simple and straightforward. What I'm saying about more spring hinges, you know, you do want as much residual stored energy as possible so that you can get the door to not only close but latch, and do so where you're not forcing so much energy on that spring where it just slams the door or gets it moving quick enough so that it just limps home on inertia. You don't want that. I'm not a fan of spring hinges at all. I don't think they should be used ever. But although there are times when you have no choice. Hydraulic control over a door is the way to control a door. There's no control on a spring, right? You just wind it up and let it go. Wind it up and let it go. Not a very reliable way to get doors to close and latch. And it's interesting in hotels, almost all hotels that I'm in, if those doors latch, they are slamming latched, which, you know, is not a problem for fire code. As long as the door latched, it doesn't mean... NFPA 80 is not talking about the long-term health of the wall, the frame, the door, the paint all around, if that door is slamming shut constantly. Although I was very recently in a hotel where that door closed very, very well. It was installed true plumb level and square. The latch bolt had a nylon insert so that when it struck the lip of the strike, it very gracefully entered, presenting very little resistance to the forces attempting to close the door. So that worked very well. I think I held it open from about 30 degrees and let it go, and it latched very well. But the majority of hotel doors like that don't. And almost all of those doors are certainly fire rated. So be mindful. Having more spring hinges rather than less gives you more options when you've already decided that a spring hinge will be how you're going to close the door. So tension is obviously easy when it comes to setting it. Screws are included. You'll note here that there are 4 wood screws and 8 machine screws. Okay. Maybe that works. It ought to be listed in the Bommer catalog what their standard is. If their standard says half wood screws and all machine screws, then there you go. That's why you get this. What if you're doing a fiberglass door and you're doing some sort of synthetic structural lumber frame? You're going to want wood screws. In the comment field when you're ordering your hinge, be sure to tell us what screws you need. It's going to be hard to come up with number 12 by 1 1/4 threaded to the head flathead Phillips drive stainless steel screws on a Saturday morning. And you're only putting 2 screws in each hinge because you don't have enough. So be mindful. Just indicate that. There's no reason for the factory to send you any more or any less than you need. And most definitely there's no reason to send an insufficient, composition of the screws that you need. Finally, there is a link below this video. Oh, there's another link below this video. It's the product catalog. Shows you the listing of the part numbers of the contract grade hinges and gives you a summary table on the second page. There's also a link below this video to the manufacturer's page where you can pull up not only all of the Bommer products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. You see the Bommer logo there? Right above it, it says Made in USA. That's a fact that Bommer is quite proud of, as am I to represent them. Any questions on the Bommer LB4390C in a 400 and a 630 or any other Bommer product, please feel free to reach out to us. And thank you.